Okay, I want to give you a bit of an introduction to this whole idea of quadratic equations. And to start that, I want to refer to some things we've done before. So before I look at quadratic equations, let's just look at linear things. Okay? Here's a linear expression. Okay? And I could think of this way. Suppose a lawyer charges you $200 for your first hour, or $200 for your visit, and then $50 an hour after that. And so, if you were going to write an expression for how much money it's going to cost you, you'd say, well, it starts at $200 right here, and then $50 an hour after that. So you could use this to calculate it. So this would be a linear expression. We learned to do things with linear expressions like factor them and stuff like this. So that's the same expression, just factored. We also learned to write them as equations, and so maybe I might look at this one and say this is the cost when you go X dollars to the lawyer. And so it's an equation now because it's got an equal sign, and we learned to graph equations, and we learned about the slope of them and y-intercepts and things like that. And so we spent a bunch of time with those kinds of things. And we even looked at linear data. And I want to look at an example of some things here with this. Here's some linear data. You can see it's linear because as x goes up by even amounts, so does the y go up by even amounts. It goes up by 3. And when you make a graph of it, it lines up in a line. And you can tell even better when you look at the graph by drawing a line through it. And we even learned to write equations for lines based on the data. So this was kind of cool stuff. We could make this stuff work. Well, I want to look at one that is a quadratic. So let me turn off this other data here so you can't see it. So here's some quadratic data, and you don't necessarily have to know that it's quadratic yet, but it's looking definitely not linear. There's not a line that goes through here really nicely. And so we're going to learn to look at data that is quadratic in the sense that it follows different patterns than linear patterns. When we looked at patterns that looked like this, where maybe we had a population of 5,000 that increased by 15% every year, that was an exponential expression, and we learned to look at data that helped us generate those things. Well, we're going to learn to look at quadratic data that will also help us deal with certain types of problems that fit this idea. The basic idea will be anything that's got an x squared in it is going to, and that's the highest power, is going to turn out to be quadratic. Here's a quadratic equation. Here's a quadratic expression. Okay, the highest power on x is 2, and so it's going to be quadratic. Here's a quadratic equation. And we'll learn to deal with those kinds of things and learn to graph them even. Okay, so kind of the last thing to look at before you get started, here's some data that, a graph of some data. This happens to be, the idea is, I'm looking at the price per cup. If I was selling coffee, as the price per cup increases, what happens to the amount of daily profit? Well, clearly, if I don't sell any coffee, or sorry, if I sell coffee for $0, in other words, if I give it away, I'm going to make zero amount of money. It's going to be pretty bad. In fact, I'd probably even lose money. And then as I increase the price to 50 cents, I'm not going to earn much money. As I increase it higher, well, eventually it's going to top out here. And so we're going to learn, among other things, to write an equation that allows us to graph this pretty easily, and we'll be able to find out exactly where it tops out, how much to charge so we make the most amount of money, and how much money we can make. So we'll learn lots of different things about quadratic data and expressions and equations. some of it will be simple, some of it will be more difficult, but hopefully you'll be able to feel okay about it and catch on and survive the thing. Okay?